Hello guys, in this video I will explain the second integration method, which is integration by substitution. To find integral of product of two same kinds of functions, then we can apply this technique. What do I mean by same kind of functions? Let's say two algebraic functions are multiplied, two trigonometric functions are multiplied or stuff or divided. We can apply this substitution method. This method is also called U substitution. So this is chain rule in reverse. This U substitution is integral version of chain rule. So we are gonna let one of the functions as u and find its derivative. So in this method, the function and its derivative exists together on inside the same integral symbol. Okay, the function and its derivative exist together inside the same integral notation. So this is a good technique when there is a function and its derivative in the same integral. All right. So how are we going to identify u and its derivative? Let's take a look at this figure. We have an integral. Let's consider this function written inside integral as a composition. This is the outside function. There's an inside function, and derivative is sitting outside of this thing. So we identify inside function. We let inside function to be u. So how are we going to identify? Inside function is generally the one that's inside under radical, if there is a radical, or if there is a power, then the base will be the inside function. So we generally have those two cases. Either there is a power, then base will be considered as u, or there is a radical, and the radical will be used as u. So let's start solving questions with first identifying u. Select gx, meaning select u in this form of the function. We have 10x dx and 5x squared plus 1. So the inside function, since there is a power, will be the base. So I will let u be 5x squared plus 1. By u, I mean gx, the inside function. So 5x squared plus 1 will be gxu because its derivative is 10x dx sitting outside. This is an exercise question. Another exercise question, select gx or u, we can say. What is the inside function? Inside function is the one that's on the radical if there is radical, which is x squared plus 1. Because its derivative is 2x dx, x dx is sitting outside. So this is our u. Okay, another question. Check it out. 3. This is not asking about identifying only u, it is also asking about solving this integral. So there's a multiplication of two different kind of two same kind of functions. Here we have 2x and x squared minus 1 on the radical. We are going to identify u first. U is the one that's inside radical. We have x squared minus 1. And we identify its derivative. Du over dx is u prime is 2x dx. In integral, let me erase this, just 2x. In integral, we use dx right beside the function, right? So let me do cross multiply. Let's get du alone. So du will be 2x dx. So I have 2x dx sitting outside, x squared minus 1 sitting inside. So I'm going to write this integral in terms of u, no more x. To solve this question easily, we are going to solve it in terms of u first. So integral square root x squared minus 1, I let this to be u. Outside we have 2x dx, which became du. Now, this is much more simpler than the given question. Now, I'm going to take integral of this instead of that one. So, let's manipulate this, rewrite this function as u to the half Then apply the power inverse power rule. Increase the power by 1, 3 over 2, divided by the same power, 3 over 2, flip it, 2 over 3 in front, plus c, right? So I am done taking derivative. After I am done taking derivative, I will do back substitution, meaning I will put the function that I put u back. I picked x squared minus 1 for u, so I will put this back. No more u now. Let's put x back. So that's it. If I want to simplify this more, I can write this as radical x squared minus 1 cubed under radical. I can take x squared minus 1 squared out of radical. X squared minus 1 outside. Inside, I have another x squared minus 1 plus c. This will be the answer. This is how we simplify reduce down the complexity of integrals by using integration by substitution. Okay, let me summarize what I did. I picked the inside function first, let inside function to be u, and took its derivative. And since in integral we have dx right beside the function, we did cross multiply. So du is, and du and u are both exist inside the same integral. So we wrote everything in terms of u. Took derivative integral of u and do back substitution. Okay, let's continue with another exercise question. Find antiderivative. Like in the previous lesson, we are going to find the integral of this function first and substitute the given point to find a specific antiderivative. So let u be the inside function. Inside function is the one that's base of the exponent, which is 4x squared minus 10. What is du? Derivative of this is 8x dx, right? So I am not writing dx under du anymore. Consider making cross product, then dx comes here. Now I have 4x squared minus 1 in the question, minus 10 in the question. I also have 2x in the question, but I got 8x. I don't need 8x. What I need is just 2. How do I make 8 2? How do I make this manipulation to get just 2? I guess by dividing both sides by 4, we'll make right side 2x dx. This is all I need. I don't need this. I just need that one. Now, let's write everything in terms of u inside the integral symbol. Integral u to the power 2 times 2x dx is du over 4. This is the new integral I'm gonna take. So there is a product, there is a coefficient here, constant coefficient. Let's move it out in front, pull it out in front. 1 over 4 will come out. I'm just gonna take integral of u squared. So integral of u squared is u cubed over 3, right? Plus c. That's it. I am done. Now I need to do back substitution. Whatever I let u to be, I'm going to put it back. So my answer will be 1 over 4. I can distribute this actually. Let me first distribute 1 over 4 and do back substitution. U cubed over 4, 12 plus c. When I do back substitution, it's going to be, u will going to be 4x squared minus 10. I have cubed here over 12 plus c. This is my antiderivative. Now, I got my antiderivative. What I need is a specific c value so that I get that specific antiderivative. I know because of the given point, my x is 2 and my result is my y is 10. 2 squared 4, 4 times 4, 16, 16 minus 10 is 6, 6 cubed is 212, 200 something over 12 plus c is equal to 10. Then isolate c, you'll get c as negative 8. So when I get c, I can easily write the new antiderivative, a specific antiderivative. 4x squared minus 10 cubed over 12 plus c, which is minus 8. Okay, that's a specific antiderivative. Okay, when you know how to apply the rule, the rest is easy. Another exercise question. We have a radical, so we will let u to be under the radical, which is x minus 1. So what is my du? Du is derivative of x minus 1, which is just 1 dx. Okay, I have x minus 1 under root u. I have dx as du. What about x? My derivative doesn't involve x. X is left alone here. So I have to do something with this x. We have to find some kind of substitution for x in terms of u too, right? All we have to do is manipulate u. How can I write x in terms of u? If my u is x minus 1, what's my x? Let's isolate x, bring 1 to the other side. U plus 1. Okay, that's all I need. I got my x in terms of u. I got my x minus 1 in terms of u. I also got the x in terms of du. Everything is written in terms of u, easier to integrate. So, in place of x, I'm going to write u plus 1. Under root, I have u. Dx is equal to du. Now, no more x, everything is written in terms of u. Now, just simplify this integral. This is u to the half. So u times u to the half, u to the 3 over 2, plus 1 times u to the half, u to the half du. Okay. I'm not simplifying the derivative. Now I will take derivative. So derivative here is increase the power by 1. U to the 5 over 2 over 5 over 2 makes 2 over 5 in front, plus u to the 1 over 2 plus 1, 3 over 2 over 3 over 2 will make 2 over 3 in front, plus u. I am done taking the integral. Now I can simplify this more by converting it into a radical. So we have power 5 over 2 means we have u squared, square root of u, plus 2 over 3, u square root of u plus... I'm not explaining converting this rational exponents to radicals because we have been doing this for a long time, especially in chapter 3, section 2. We did this a lot. So I'm not going to explain the conversion here. You already know. So I'm done simplifying, manipulating everything. Before I do back substitution, I do all algebraic manipulation in terms of u. That has to keep things less complicated. So I got my answer in simplest form. Now it's time to do back substitution. Okay, I'm good to go. So when I do back substitution, I'm going to have 2 over 5. U was x minus 1. Squared square root of x minus 1 plus 2 over 3 x minus 1 square root x minus 1 plus c. It is such a long answer, but this is what it is. This is our answer. This is an exercise question, and there is a similar ministry exam question. Okay, I think I solved questions involving radical powers. I just didn't solve question involving trigonometric function. Let me do one last question about trigonometric functions. 2023 second attempt ministry exam question. So which one is u? U is the one that has the power, which is cosine x. What is the derivative? Du is negative sine x dx. I don't need negative. I don't have negative here. So divide both sides by negative. So negative du is sine x dx. Now, I can write everything in terms of u. 0 to pi of cosine is u now. U squared times sine x dx became negative du. I can take negative out in front. U squared du. Now, increase the power by 1, divide by the same power, plus c will be the answer. So I am done solving the, I am done, there is no c, sorry. I am done taking the integral. Now we are going to do back substitution. Before I input bounds back, these bounds are for x, so I have to make u back again. Let's do back substitution. What was u? U was cosine. So it's equal to negative cosine x cubed over 3. We did back substitution. Now we can input the bounds. So negative cosine pi cubed over 3 minus cosine 0 cubed over 3. The answer is minus. Cosine pi is negative 1. Negative 1 cubed is negative 1. Negative 1 over 3 minus cosine 0 is 1. 1 cubed is 1. Negative 1 over 3. I got negative, negative, negative 1, 1, 2. Negative, negative makes positive. 2 over 3 is the answer to this ministry exam question. Okay, we have been doing the same stuff since the beginning of this lesson, right? We picked our u as an inner function. It is always, generally actually, the base of the power or stuff on the radical, and then you differentiate this function. You get the function and its derivative together. You wrote everything in terms of u and do back substitution, find the answer. So we are done with this section.